Hello everyone, this is Old Mechanic Technical Workshop. Today we will talk about the role, failure symptoms and inspection methods of the hall sensor, a component commonly used in washing machines and air conditioners. When repairing home appliances, you may encounter situations where the motor itself is normal, but it does not rotate properly, the speed becomes unstable, or error codes appear. In particular, front-load washing machines may display motor-related error codes such as LE, 3E, and 8E, while air conditioners may experience fan motor failures or outdoor unit rotation problems. One of the common causes of these issues is a faulty hall sensor. Although it is a small component, the hall sensor plays a very important role in detecting the motor's rotational status. When the hall sensor operates normally, the PCB can accurately determine the motor's speed and position, allowing it to control the motor correctly. However, if the hall sensor malfunctions, the PCB can no longer determine whether the motor is rotating properly, which may trigger protective shutdowns or display error codes. Let's first look at how a hall sensor works. A hall sensor is an electronic device that detects changes in a magnetic field. As the motor rotates, the magnet inside the motor rotates as well. The hall sensor detects the movement of this magnetic field and converts it into electrical signals. The PCB receives these signals and calculates how fast the motor is rotating and its exact position. In simple terms, just as a speedometer tells you how fast a vehicle is moving, the hall sensor tells the PCB how the motor is rotating. In front-load washing machines, the hall sensor is usually installed near the rear section of the motor and continuously sends rotation information to the PCB. Using this information, the PCB controls low-speed operation during washing cycles and high-speed operation during spin cycles. If the hall sensor signal is lost or becomes abnormal, the PCB may determine that the motor has stopped or cannot be controlled correctly, causing the machine to shut down. Now let's look at the symptoms of a faulty hall sensor. The first symptom is that the washing machine fills with water, but the motor does not rotate. Water supply and drainage may operate normally, but the wash drum may not move at all, or may move briefly before stopping. The second symptom is spin failure. The machine attempts to start spinning, but the rotation speed cannot increase properly and repeatedly stops. The third symptom is the appearance of motor-related error codes such as LE, 3E, and 8E. These errors may not only be caused by motor problems, but also by hall sensor failures. The fourth symptom is sudden interruption during operation. Even if the motor is rotating normally, a loss of hall sensor signals can cause the PCB to stop operation for safety reasons. The fifth symptom is severe vibration or unstable motor rotation. If the motor position cannot be detected accurately, motor control becomes unstable. So what causes hall sensor failures? The most common cause is aging. After years of operation, the internal electronic circuits may deteriorate, resulting in weak or unstable signals. The second cause is moisture and water leakage. Because washing machines operate in a humid environment, condensation or leaks can damage the hall sensor circuit or connectors. The third cause is poor connector contact. The sensor itself may be working properly, but loose or corroded connectors can interrupt signal transmission. The fourth cause is broken wiring. Continuous vibration can cause wires to break or insulation to become damaged. The fifth cause is PCB failure. In some cases, the hall sensor is functioning correctly, but the PCB cannot properly read the signal. Now let's discuss the inspection procedure. Before performing any inspection, always disconnect the power supply. Remove the rear panel or lower cover of the appliance and locate the motor and hall sensor. In front-load washing machines, the hall sensor is typically mounted around the stator or behind the rotor assembly. Start with a visual inspection. Check whether any connectors are disconnected. Inspect the wiring for damage, cuts, or pinched sections. Also check for rust, corrosion, or contamination on the connector terminals. Next, inspect the connector connections. Disconnect and reconnect the connectors firmly. In many cases, simply correcting a poor connection can solve the problem. Then use a multimeter to measure the supply voltage. Most hall sensors operate with DC voltage supplied from the PCB. Depending on the model, this may be 5 volts or 12 volts. Verify that the proper voltage is reaching the sensor. If there is no supply voltage, the problem may be in the PCB or wiring. If the supply voltage is normal but no signal is produced, the Hall sensor itself is likely faulty. For advanced diagnostics, technicians often use an oscilloscope to check the pulse signal. When the motor is rotated slowly, the Hall sensor output should produce a consistent pulse pattern. If there is no signal change or if the waveform is irregular, the Hall sensor may be defective. When replacing a Hall sensor, always use the correct part designed for the specific model. Even if sensors look similar, their electrical characteristics and connector types may differ. After replacement, make sure all connectors are securely fastened and the wiring is properly routed. If wires contact moving parts or rotating components, another failure may occur. To summarize, the Hall sensor is a critical component that detects motor speed and position. When it fails, the motor may stop rotating, spinning may fail, and error codes such as LE, 3E, and 8E may appear. When diagnosing the problem, it is important to check the connectors, wiring, supply voltage, and sensor output signals in sequence. Before replacing the motor, always inspect the Hall sensor and wiring first, as this can save unnecessary repair costs. That concludes today's topic. Understanding the role and inspection methods of the Hall sensor will help you diagnose motor-related problems more accurately. Thank you for watching. This has been Old Mechanic Technical Workshop.